Hi, this is Jason Molesky. In this example, we'll take a look at how we can use Table D to perform a simulation. At a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at the school assembly. The two lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn by a student council member who was from the AP Statistics class. When both golden tickets went to members of that same class, some people thought the lottery had been rigged. Now, there are 28 students in the AP Statistics class, all of whom are eligible to park on campus. So our task is to design and carry out a simulation to decide whether it's plausible that the lottery was carried out fairly. So we state our problem. What's the probability that a fair lottery would result in two winners from the AP Statistics class? Our plan is to use Table D to simulate choosing the golden ticket lottery winners. Since there are 95 students in the lottery, we'll label the students in the AP Statistics class from 01 to 28, and the remaining students from 29 to 95. Numbers from 96 to 00 will be skipped. Notice each student receives a 2-digit label. Next, moving left to right across the row, we'll look at pairs of digits until we come across two different labels from 01 to 95. The two students with these labels would be the winners of the prime parking spaces. We'll record the number of winners from the AP Statistics class in each of these trials. So let's take a look at a row in Table D. I've labeled it here in 2-digit blocks to make it a little bit easier to see. The first two numbers we see, 55 and 58, both fall outside the range that included the AP Statistics students. Remember, those students were labeled 01 to 28. So if we consider this our first repetition, we can see that 0 AP Statistics students would have been simulated to win a golden parking spot. Next, 89 and 94 both fall outside of the range of AP Statistics students, so again we have 0 from the class. And in the next repetition, we see we have a label 04, which would fall inside the range of AP Statistics labels, and the next label of 70, which would fall outside the range. So in this particular simulation, we have one student from the AP Statistics class who would have won the golden ticket. Continuing on, repetition 4 gives us 0 students. In repetition 5, we see we had to look at 3 numbers because the number 98 fell outside of our range from 01 to 95. So in this case, we can see we had one student from the AP Statistics class, the student with the 10, and one student outside the range, 43, again having one student with a golden ticket from the AP Statistics class. If we continue this procedure on for repetitions 6 through 9 and continue down the line until we have 20 repetitions, we can see how many times we'd have two students from the AP Statistics class winning the golden ticket lottery. In fact, we can see that occurred here in repetition 10, again in repetition 16, and once more in repetition 18. So out of the 20 repetitions, we had 3 instances where two individuals from the AP Statistics class won the golden ticket. So suppose we did this for 30 more repetitions, and there were an additional 2 times when both winners were in the AP Statistics class. Well, we'd conclude that in our simulation of a fair lottery, both winners came from the AP Statistics classes in 5 out of 50, or 10% of the repetitions. In other words, in about 1 out of every 10 times the student council holds the golden ticket lottery, this will happen by chance. That is, in about 1 out of every 10 times, both winners would come from the AP Statistics class. It seems plausible based on this that the lottery was conducted fairly. For some additional practice with using simulations with Table D, try exercise 19.